As we all know, the true and tested way of learning new technologies in software engineering is to just apply them yourself in a personal project. One disadvantage this can have, though, is that this application, this applying the skill to a real-world example might be really difficult. I have yet again run into this as I'm trying now to get a really fundamental and deep understanding of SQL in a personal app. SQL for some reason was always a little bit intimidating for me. And in all the personal apps that I've built, I used MongoDB because it was back then recommended to me. I mean, this is like many years ago, around 2017-18. And now I'm sort of locked into the technology. So I wanted to switch over to SQL, but the data structure that I had been working with is deeply nested JSON. And so to translate all of this into a relational database, it is really much more difficult than the typical run-of-the-mill examples you find online. So I've been trying to wrap my head around converting those nested structures into a proper normalized relationship within SQL. My takeaways here are that it's best to approach it from the most fundamental aspect. For me, that means writing my own PostgreSQL queries and working with that. It's really cumbersome, but I think it lends the best fundamental knowledge, after which using abstractions makes more sense because you know what those abstractions do and it becomes much easier to debug. One such example is that I initially started using certain ORMs, or object relationship mappers, like initially it was Prisma, then a little bit of type ORM, then some GORM from Golang. And yeah, I noticed that it's better to just use raw PostgreSQL and insert a schema into my database and then fill it with data and then retroactively match it up with the ORM, because there's problems you run into using these ORMs that are where it's unclear if they're because of the limitation of the ORM. It's especially terrible if you find a vague similar problem online on GitHub issues and then they just like debate workarounds to the ORM, so you're not sure if it's you're trying to approach the problem from the wrong angle or if the ORM is insufficient for what you want. And so using the raw SQL has proven to be really good there because I get to learn the more raw constraints and benefits of the language. One thing I recommend here is, by the way, to start with the wrong and simple approach. For example, I'm not using any constraints or other things, and then later I will add those as I get a more intuitive understanding on how the whole thing works, and you get a good understanding on why you need advanced concepts or constraints or like whatever features there are, extra features that you would usually use in production or at your job. Yeah, not using them, you will run into problems, but you will learn the more fundamental blocks, and that will help you to differentiate from those to the nice to have add-ons. And of course, it's vital to make that switch then to the production ready way of writing things. But at the same time, it's really easy for us engineers to overwhelm ourselves with all the things we have to learn. I'm going to show you some examples of what I've been building here. One thing I found, it's quite easy for me to build prototypes, but I run into heavy limitation on the backend side because my data model is not good enough. It is too sort of hard coded, and then I need certain things to be dynamic and it's not possible. So I've been trying to find a good schema that works well. One such example is I've been dealing with a language learning, I've been dealing with words, and so I would just have a word object that contained the literal translations, so it would have an English and Spanish column or field that would have those values, but you run into limitations with this really quickly. And so now what I'm working on is a word object or schema that just has a language and the actual string, and then you have the word pair where you pair those words together, and this obviously is more flexible and you can just like keep attaching stuff, and then you can just dynamically query what you want. but you can separate the things that you need to separate.
So here you can see just the project I've been working with, and as you see, I used Prisma, and within Prisma there should be the prisma.schema file, and already there I run into some problems. By Prisma it was complaining because I tried to use a distinct language schema, which I then would use here in the language pair and in the various other schemas that were using this language. Sorry, by the way, for the syntax highlighting, but I think I disabled the extension because I've not been working with Prisma for a while. As I run into this problem, I couldn't really find a solution for Prisma because Prisma was not big enough for these fine-grained problems. Instead, I just found Postgres or SQL related topics. But at that point, I might as well use the underlying thing, which is SQL, to solve these problems. And there I have actually not run into this problem doing similar things. Then because the problem in Prisma was that it wouldn't allow for there's in language learning the L2 and the L1, the native language that you're already possessing, in my case English, and the L1 that you're trying to learn Spanish. So they both point to the language schema, yet this was not possible somehow in Prisma. And so this is sort of my attempt there. And then I moved on to this test SQL file where I was just trying to seed my database with the sort of syllabus, with the corpus of text, with the dictionary, you could say. And I've been just experimenting a little bit. And my main goal was to get the most difficult part working. What is not so difficult is the thing with the words. However, I have also grammar, and I scraped this from some website, and it's quite nested and difficult to work with. And so converting that into a SQL relationship schema is not easy. And here you are seeing my work in progress on that and me debugging stuff and trying to overcome like sub problems. And one thing I try to move away from this whole thing because it's quite cumbersome to do this all just in JavaScript. So I have this helper functions here that insert stuff. I'm not a fan of this, but I'm not sure how to avoid it the best way. But at least for seeding the database, I found that it's better to have like a proper SQL table, SQL file that does the bidding for me. I'm still not completely behind this stuff. Like ideally, I would like to have it drop everything I do and then create it from scratch. However, I'm gonna keep that for the future, really tackling that later and get comfortable with the nitty-gritty first, which I had some success today. Concretely, that meant that I created a word table, as already mentioned, and there are word pairs, and I successfully created those, but I had some struggle querying them. And then lo and behold, ChatGPT came to my rescue, and I was able to get a query that actually worked, which completely surprised me. You can see that query here on this terminal, which to me speaks to the power of SQL, that you're able to combine things like this and that. Anyways, I was confused about what ChatGPT did here with the W1 and so on, because I haven't named it anyone. And then lo and behold, I could ask it and it would explain to me some nuances of the SQL stuff. I believe that once I have a solid data model and a better understanding of SQL, it is then quite powerful to have a good schema. And from this, it's easy to build various prototypes and front-end applications that do various things. And tackling this schema of the grammar is one of the most difficult parts so far. To give an example of what I'm dealing with, I have this originally Basin, so a mongoDB structure, mongoDB documents, where I have a English word check. It has a bunch of data, like synonyms and so on and so forth. And then I have this grammar here, which then you can see it here down in the English section. So it's all nested. And here you can see that there's a whole bunch of paradigms, and those paradigms contain the relevant information for that paradigm. Here I printed out some of the list of paradigms, so you can just imagine that maybe this one corresponds to this one. And so they cover all of these grammatical concepts. And the idea at the end is, of course, having a language learning app that greatly helps you with going through those grammar topics.
I hope you got some insight from this knowledge sharing. I hope you have a great day. Bye.